Well, welcome to the Solid Edge simulation test drive, and for that we're going to use our micrometer assembly that we've been working on in the part in assembly test drives. And I do want to point out that in those test drives, by changing the shape of the micrometer frame, you've seen how easy you could modify the synchronous features. Now you're going to simulate the effective forces on two different shapes of this micrometer frame itself. When you first open up the file, I suggest you right mouse button click on the top level assembly and just click on the activate, and basically that just activates all the parts so you don't have to do them individually. Now the first step in this process is we want to create a study. You're probably sitting at the Home tab, so go to the Simulation tab and then simply click on New Study. Basically it's going to bring up a dialog. Now it says apply a linear static. We have options here for linear static, normal modes, or linear buckling, and then tetrahedral mesh. Linear static analysis is appropriate to calculate displacements, strain, stresses, and reaction forces under the effect of applied loads. Tetrahedral meshing breaks apart into a number of smaller volumes for analysis. For most models, tetrahedral meshing is quite appropriate, so we'll go ahead and click on the OK button. The next thing it's going to ask you to do is, what geometry do you want to analyze? Obviously we can analyze more than one piece of geometry in an assembly, but in this case we're just concerned about the frame here. So we're going to go ahead and click on that and then click to accept it. Now that completes step one. The next step, we're going to talk about applying a force. In order to do that, let's go ahead and start with step two, applying the force. And the first thing they'll ask you to do is change your face priority. And then what we're going to do is click on the force under the loads and constraints. Under the loads we have force, and I'm going to select this front face. Now immediately I'm going to drag this out of the way. You'll see the arrow is pointing away from that. Now you can easily use this steering wheel and change the direction, but you can also just flip the direction using those green arrows. And then we want to change this value. I'm going to change it to 6,000 millinewtons, and by right mouse clicking it accepts and applies the force to our study, and you can see the arrow that it creates. Of course, as the spindle is tightened while measuring an object, a force is applied to this left side of the frame we just identified, and the simulation will model that force as if it was applied equally across the planar face inside the frame. The next thing that we want to do, which is step three, is to apply a constraint. Now constraints identify portions of the model that are fixed, and in this case the right face of the frame right here is held in place by the person using the micrometer. So we'll come up to the fixed option under constraints, and we're going to identify that face, and by right mouse button clicking it will accept it and apply a fixed constraint. Now you can accurately simulate more realistic design scenarios to reduce physical prototype cost with additional loads and constraints, such as these new loads in ST3, such as torque and bearing, and also new constraints for bolt and edge connectors, as well as the user-defined constraints, which are also new in ST3. Now that concludes step three. We have the study created, we have the force and the constraints applied. So the next thing is to mesh and solve and see what our results actually look like. So if you come up to the mesh button and you go ahead and click on the mesh and solve and do it all at one time. Now we are going to apply a mesh, which is a system of grid points that overlay the model geometry and solve the study. The system processes the information that we've defined and solves the study. When the solve is complete, it's going to display the results on the model, and simulation results ribbon is also displayed. Now you can see that it goes from meshing to solving to processing the results, and you can see that it's almost completed here. The whole idea here is this is all built into Solid Edge, so it's very simple for a user, once he's defined his model, to quickly run a simulation to see if his model is going to stand up to the forces that are applied. Now if we come over to color bar, you notice that our geometry is a little bit underneath there. We can drop that down to the bottom and get a better idea of what that information is. But you'll notice it does give us some pretty good feedback. Another thing too is if we don't want to look at stress, maybe we want to look at displacement, we can change it to displacement to give us a totally different look and feel on our ribbon as well as our geometry here. Okay, so this basically completes step 4. We were able to get to our results very quickly. So what I wanted you to do is go ahead and close the simulation results, and let's go to step 5. Now you'll also notice not only the simulation tab here, but under Pathfinder, the options over here, we have a simulation tab. And when I open that up, there's our study. There's the loads and constraints that we define. You notice they highlight. I can expand them and it shows that it's a force. I can edit, create studies, do everything from a right mouse button, click on the study, whatever I want to do at this point. What I'm going to ask you to do is turn off the loads and constraints. We don't need to see those at this particular time. And then what we're going to do is just talk a little bit more about this. I do want to point out that you can have multiple studies within a single design. So if I could have 5 studies in this design. I can also copy and paste loads and constraints from one study to another. So it makes it a lot easier when you're defining and you want to run multiple studies. You can use the same loads and constraints if needed. Now the 6th step is to make a change to the part. So we're going to edit this part in place. Let's go back to the part priority, select our model, and then click on the edit in place. It takes us into the part environment where you're going to notice there's a dimension for the height of this frame. What I want you to do is click on the 46 so the arrow is down. If it's not, you can switch this way just by using the arrows. Make sure it's going down. And we want to scroll a little bit or key in a value of 52 millimeters. So making design refinements, you can see, is real fast and easy within synchronous technology. And now we have an updated model. The 7th step is to mesh the part again. Obviously, it shows us that this study, the green means everything's good, the yellow means there's a caution, meaning we have some things that are out of date. So I'm just simply going to click on that mesh button and mesh and solve again, and to let it remesh this part. Now we talked about what this actually does. It creates the mesh across this part. So it's going to remesh, resolve, and then create a new study with the new geometry that we've changed very easily using Solid Edge with synchronous technology. Again, the beauty of simulation being built into the part environment or the assembly environment is that our users, most of the time just common engineers that build parts for a living, don't have a big background in analysis, but they can still get a quick analysis on their parts and make sure that they're going to work under the application that they're going to be applied to. Okay, so our study is created very quickly. Again, you can make changes to the color bar. You can move the ribbon bar to the left or to the right, but it gives you lots of options for different types of display. One of the things that we want to do is just simply run the animation tool. You notice it puts the part in an animated state. Basically, as the animation displays stress results over time that it's moving, notice the options available on the command bar for controlling the characteristics of the display. When that's done, we can go ahead and close that. And then the final thing is to create the report. We can key in our information. We'll just key in Mark. For company, I'll just key in Siemens. And we'll go ahead and create a report. And what it's going to do is it's going to create a Word document. Now you notice it's taking snapshots of each of the results. And then it will bring a Word document up. And it's going to show those results. Now these are all hot links, so we can go right to anything in the file, but as I scroll down through here, you're going to show that it shows all of the appropriate information. There's the stress results, the factor of safety results, anything that you're looking for, displacement results. And we can close and save that file. It's a Word document now. We'll go ahead and close our simulation results. This basically concludes our Solid Edge simulation test drive, but hopefully you've seen how simulation offers the users a quick and easy way to simulate their parts within Solid Edge ST3.